Hello class, today we're on 5.5, integration by U substitution. U substitution is a method we use when we're doing the opposite of the chain rule. So we're doing like the inverse chain rule. You can think of it like that. So let's just go over a few examples. So the steps here, there are 4 of them. The first one is find U and du. So U will generally be will be the longer one. What you'll see here is and U will generally be inside of something, and du is just going to be the derivative of whatever U is. And then 2, get the integrand, or what we're integrating, in terms of only U and du. We don't want any x's in there anymore. Then at that point we want to integrate. And then after that, we want to substitute our x values back in. I said substitute u back in, but substitute x back in. And then maybe we can add a little note here. And don't forget plus c. Very important. Okay, so let's go straight into some examples here. So looking at this first example on the left here, our first step is we need to find u and we need to find du. So u is going to be this thing in the parentheses, and you'll get better at this as you go through. U, I can say, is negative 3x to the 4th minus 2. Well, du would just be the derivative of that, so strictly take the derivative of u. So it's going to be negative 12x squared, or cubed, dx. And we do want to include a dx in there. So, now let's see if we have everything that we need in order for our u substitution. So this part in the middle, this is our u. And then on the outsides here we have du, negative 12x cubed dx. Well, negative 12x cubed dx. So, my next step is I'm going to get the integrand in terms of u and du. So I'm going to substitute. So we're going to have, I'm going to say u to the 5th, because we're u's to the 5th power, du. Awesome. Now step 3, we want to integrate. So just using the reverse power rule here, raise the power by 1 and divide by that value. So we can say u, or we can say u to the 6th, or 1/6 u to the 6th is the antiderivative of u to the 5th. And then the du goes away since we took the derivative, or since we took the integral. Now that we integrated, our 4th step is we just want to substitute x back in, and don't forget our plus c. So u is this business right here, so we're going to substitute that back in for u. So we're going to get 1/6 negative 3x to the 4th minus 2 to the 6th power. And there, plus c. And there you have it. That's u substitution for the first example. Let's take a look at another example. Here now we have a negative exponent, but it's going to work the same way. So let's go ahead and find our u and du. So u is going to be this business inside here. It's going to be, let's see, negative 20. Oh, I'm sorry, I took the derivative. U is strictly going to be this. So negative 5x to the 4th minus 1. And du is going to just be the derivative of that. It's going to be negative 20x cubed dx. Notice if we picked the negative 20x cubed to be u, our du would not include this. So you just kind of get the foresight after doing these a little bit. So we just want to make sure that we have everything included here. So let's see if we do. This business in here is our u, and then our du, negative 20x cubed dx. We have those on the outside. So now we can go ahead and substitute. So this is going to be u to the negative 3rd power du. And now we can integrate. Step 3. So let's see. This is going to be, so it's negative, so think, we're still going up on the number line. So this is going to be u to the negative 2nd power times negative 1/2. Right? It gets kind of tricky when we're dealing with negatives because we're still going up, right? But remember, when we're negatives, going up actually gets us closer to 0. All right? So now that we integrated, we just substitute back in. So we're going to have negative 1/2 times u. Well, u is negative 5x to the 4th minus 1 to the negative 2nd power. Oh, and then plus c. And there we have it. All right, let's do a couple more here. All right, so here we have a fraction now. And I'm going to utilize negative exponents in a little bit. So keep that in mind. Let's find our u first. Our u is, in this case, is going to be this thing on the inside. So it's going to be negative 3x to the 4th plus 5. And our du, just take the derivative of that, is negative 12x cubed dx. And let's see if we have everything. Well, my u is here on the bottom, and my negative 12x cubed dx is here on the top and on the side. So I can rewrite this as du over u to the 5th. Now, this is what I like doing when I have an exponent in the bottom. I like to convert it to a negative exponent. Remember, if we have a positive exponent on the bottom, we can take that whole thing to the top, and the exponent just becomes negative. So I'm going to do that. So just to make life easier for us, so we can better clearly see what's going on. So I can say u to the negative 5th du. And then now this is much easier to integrate. So we're going to have, we're going to raise the power and then divide by that power. So this is going to be u to the negative 4th, and I can divide by negative 1/4. Right? Remember, going up in powers, we're getting closer to 0 since we're negative. And then I don't need my du anymore because we integrated. And then now we just substitute back in. So it's going to be negative 1/4. U, but u is negative 3x to the 4th plus 5 to the negative 4th power. And there we have it. All right, this last example is a little different. So let's go through this and see what we get here. See how things unfold. So let's start off by finding our u and du. So u is going to be this business inside. It's going to be the 3x to the 4th plus 4, which means my du is going to be the derivative, which is 12x cubed dx. Now, notice what's going on here. The u, we have this inside the u, but we don't necessarily have 48x cubed dx. We have instead 12x cubed dx. So what we want to do in this case is we want to manipulate the mathematics. So what we're going to do is think, okay, what can I multiply this by to get 48x cubed? And in this case, it'd be 4. So what if I multiplied both sides by 4? So 4 du equals 48x cubed dx. So this is what we're going to use now. So I can rewrite this now as, well, my u is on the inside, so u to the 6th plus our 4 du. Or sorry, not plus, times 4 du. So we just substituted because we need this one, because this one is the one that has 48x cubed. This one does not, so we can't use just strictly du. So we need the 4 du in there. And now we can integrate. And so when integrating, if we have a factor that's just a constant, we can actually move that out front. So I can rewrite this as 4 u to the 6th du. So whenever we have a constant, you can always just move it right to the front. And then let's integrate this. So 4 stays there. Nothing happens to 4. And let's see. This is going to be u to the 7th times 1/7. Just like that. Awesome. So now we can just substitute right back in. Well, we can make this a little nicer. We can say this is 4/7 u to the 7th power, and then just substitute our x values back in. So 4 to the 7, or 4 over 7 u, which is 3x to the 4th plus 4 to the 7th power. And that's it. So that's integrating by U substitution. I hope this video helped. Of course, as always, just let me know if you have any questions.